Okay, hopefully you can see that screen saying integration by substitution. If you could just let me know, Becky, if you can see it, that would be great.
Yeah.
Okay, so apologies, Upper Sick, that not many of you are there. I think that's my fault. I tried to schedule the meeting yesterday, and I could see when I looked a few minutes ago that it hadn't actually fully processed. So I'm not surprised many of you aren't there. So this is the next bit that we'll need to look at when you've had a chance to do the bits before. So sometimes the what you need to integrate can be quite complicated. And you can make it simpler, something simpler to integrate by using a substitution. And vast majority of occasions in the exam, they would tell you what substitution to use. So as it says, in your exam, you will often be told which substitution to use. Otherwise, I think in an exam situation, not that it applies to you guys, but it's a bit unfair because you might guess the appropriate substitution and it will work first time round, or you might only get it the second or third time round, which is obviously using up a lot of time. So I think it's worth assuming that they would give you this substitution to use. So I just wanted, there's lots of examples and I suggest you work through them all, but I just wanted to run through 2 or 3 of them just so you get the idea. So say you've got this equation here, they're asking you to integrate x multiplied by the square root of 2x plus 5. Now, what they're suggesting you do is use the substitution u equals 2x plus 5. So what you've got to do, every single bit of the x expression has to be replaced by u equivalents, okay? So let's start off by just starting with our u equals 2x plus 5. Now, when we differentiate this with respect to it, hi there, all right? Can hear you. So when you go into differentiate u equals 2x plus 5 with respect to x, so du dx equals 2, because obviously the differential of 2x plus 5 is 2. Now what we want to do, we want to make dx the subject. So if we multiply by dx and then divide by 2, we're left with dx equaling a half du. So that's just rearranging that. Okay, multiplying by dx, dividing by 2, we can see that dx equals a half du. So that's the first bit. We know we can replace the dx with half du. Now let's move on then to the square root of 2x plus 5. Well, that's exactly what, well, that's just going to be the square root of this. So the square root of 2x plus 5 is the square root of u, because the substitution we're using is u equals 2x plus 5. So the purple bit, we can replace the square root of this with the square root of u. And obviously the square root of u is u to the half. So we've now got the yellow bit in terms of u, done here. We've got the purple bit in terms of u. And then finally, we just want to get x in terms of u. So it's clearly that's just rearranging this to make x the subject. So that's taking away 5 and dividing by 2. So each of the 3 components of the integral can be replaced with u versions. Okay, the half du is replacing the dx, the u to the half is replacing the square root of 2x plus 5, and the x is being replaced by u minus 5 over 2. So there we go. That's just literally substituting in our u equivalents. Everything's in terms of u. U, du. Now then, just sort of following through the algebra. So we've got a half here and a half here. Half times a half is a quarter. So we're left with a quarter of this. And then multiply by the u to the half. We get this here. And then multiply. And then we can just go and integrate that. Okay, with respect to u. So adding 1 to the power, dividing by the new power. But this is easy to integrate. At the beginning, the x version was not easy to integrate. So we then integrate with respect to u. And then finally, of course, u is something we've artificially introduced. So we need at the end to go and replace our u's with our 2x plus 5s to give us this final integral here. So what you'll find with these, you will need to do quite a bit of practice to sort of get into the swing of things. But in short, it's just substitution. So everything in terms of x has to be replaced by everything in terms of u. Then you integrate, and then you substitute x back in. Now, what they've done is the second part of example 12. They've shown that on this occasion, it would have worked perfectly well as well if you'd had a different starting point. So for part B, they've just gone and said, well, how about doing the same integral, but on this occasion, we're going to use the substitution u squared equals 2x plus 5. So they're just showing you that on this occasion, it's not always the case, either of these two substitutions would have worked equally well. So it's the same idea. So our starting point on this occasion is u squared equals 2x plus 5, because that's the substitution they've asked us to do. So differentiate this. So if you remember your implicit differentiation, when you differentiate this, you're going to get 2u du dx equaling 2. The 2's cancel. And then if we multiply both sides by dx, we're left with dx equaling u du. So that's fine. So we can replace the dx with u du. The green bit, because this is our starting point, okay, when we square root both sides of this, we get u being the square root of 2x plus 5. So the square root of 2x plus 5 equals exactly u. So we're going to just replace the square root of 2x plus 5 with u. So we've got the yellow bit in terms of u, we've got the green bit in terms of u, and then finally we just need to get x in terms of u. So we're just going to rearrange this, making x the subject. So we take away 5 from both sides and divide by 2, giving us the purple bit. So we can replace x with u squared minus 5 over 2. So each of these three components are now replaced with u versions. We then do the algebra. So we've got u times u, which is u squared, and then multiply the bracket by u squared. So that's giving us u to the power of 4 minus 5u squared all over 2, or breaking that down into the two terms, we've got this. Integrate that, so add 1 to the power, divide by the new power, we get this. Then finally we substitute back in to replace u with x. So remember that x is, on this occasion, u equals the square root of 2x plus 5, so we get this. And obviously, the answer we get at the end of the day is the same as we did with part A, because it was the same integral we had to do. We just used a different substitution. So this is just quite a nice one, where both substitutions just made things simpler. If you were not given the substitution to use, and you tried to do your own substitution, you might find you go from something complicated to something equally complicated, so it hasn't really been successful. So that's why 99 times out of 100 in exam conditions, they would tell you which substitution to use, because it's a bit trial and error. Now, there are a lot more examples, but I just wanted to talk you through one more. Okay, so example 13, they're telling us to use this substitution here to integrate this here. Okay, so so that's what we're going to integrate. So and we've been told to let u equal sin x plus 1. So let's just kick off by integrating, differentiating u. So du dx equals cos x. Multiplying both sides by dx, you'll see that du equals cos x dx. Now that's nice, because that's picking up two of the terms straight away. So that cos x dx is just being replaced with du. So we're going to replace the cos x dx down here with du. That's mopping up both of these yellow bits. Okay, so that's the yellow bits converted to u. Now we know that sin x plus 1 all cubed equals u cubed, just cubing both sides. Okay, so so sin x equals u minus, what am I saying here? So sin x plus 1 all cubed equals u cubed. So that's fine. So obviously we're replacing the sin x plus 1 all cubed with u cubed. And then finally, we want to replace the sin x. So clearly, we're just taking 1 away from both sides. So u minus 1 equals sin x. So that's how we replace the green term. The sin x is replaced by u minus 1. So again, you just got to work your way through methodically, replacing all the x components with u components. So we're going from x stuff dx to u stuff du. Once you've fully substituted in replacing each of these terms, it will be an easier thing to integrate. Clearly, that is easily integrated. That could not be. So obviously down here, we just add 1 to the power divided by the new power, giving us this. And then finally, we replace u with our sin x plus 1. So there are more examples, but I'm just going to make this video too long and just bore you silly doing too many. I just wanted to talk you through 2 or 3. Okay, so that's it for now. Again, I apologize to the majority of you who didn't really have the opportunity to join this lesson, because when I tried to schedule it yesterday, it didn't successfully schedule on Teams. So it was only those of you who picked it up last minute were able to attend. So sorry about that. This is going to take you a while. So I'm anticipating this is today's lesson, the next lesson, and then I think after that we'll just touch base and see how well you guys are keeping up, and see whether you want more time before we move on or not. I mean, it's obviously it's a strange situation, isn't it? Because we don't, in a way, we don't have to do this, but I just think you know, just it's good for the soul to actually finish the syllabus. It seems a bit pointless to not actually get to the very end of the syllabus, whether you choose to take the unit tests or not. And I guess those of you obviously who are going to go on to do maths-based things at university, it's obviously clearly important that you've covered all of the A-level syllabus. Okay, guys, hope you're all keeping well. That's it for me. I'll see you soon.
Thank you.
Cheers, guys. Cheers, Dom. Bye, guys. Oh, well done, Callan. You joined us well. Well done. Okay, cheers, guys.